Number 6 from Rational Equations 1. Unfortunately, I filmed it in and the sound did not show up in the video. So let me go back here and do this for us. This is the function. I want you to think of this as simply y equals 2 over x minus 3. And this represents a vertical shift down by 2. The next thing we're going to do is we're going to talk about the degree, which is the highest exponent on a variable in the numerator and the denominator. And when you don't see a variable, in this case in the numerator, it's the same thing as x to the 0 because anything raised to the 0 power is 1. So this does not impact the value of this fraction by attaching an x to the 0 since anything to the 0 is 1. So I can see that the degree in the numerator is 0 and the degree in the denominator is a 1. Whenever the degree in the numerator is less than the degree in the denominator, we will always have a horizontal asymptote of y equals 0. But in this particular problem, remember, we have a shift down by 2. So I'm going to take that horizontal asymptote and I'm going to drop it down 2. So the equation y equals negative 2 will be my horizontal asymptote. So I'm going to come off to the side and I'm going to go to y equals negative 2, making that horizontal asymptote. Now to figure out what the vertical asymptote is, I'm going to come back, my vertical asymptote, and just as a little side note, we don't want to just write negative 2 as a value. We want to write it as an equation. So y equals negative 2. Why is it y? Because it cuts through the y-axis when we draw it. For the horizontal asymptote, for the vertical asymptote, it will always be x equals. And we're going to go into the denominator. We're setting that equal to 0. So x minus 3, setting it equal to 0, and solving. I'm going to add 3 to the opposite side, and I get x equals 3. 1, 2, and 3. Okay, let's go ahead now. Using algebra, remember we're not supposed to use a graphing device. Using algebra, let's identify the y-intercept. So to identify the y-intercept, I know that x is always going to be 0. So I'm going to come up here to this original problem, and I'm going to substitute 0 in for x. So I have y equals 2 over x, 2 over 0 minus 3 minus 2. Let's see if I can use another pen that's not dying on me. Y equals 2 over negative 3 minus 2. And we have a couple different ways that we could combine these. Some people like to do common denominators. Other people like to use the Macfarlane method. Whatever works for you. I'm going to take this negative sign and I'm going to push it up with the 2 on top. As long as this negative sign is used one time, it doesn't matter if it's on the top, on the bottom, or in the middle, as long as it's used just one time. So this is going to be minus 2 times 3 is 6 over 3. So 6 over 3 is the same as 2. There's your subtraction sign. And we have 2 over negative 3 right here. Okay, so negative 2 minus 6 is negative 8 over 3. But that doesn't make a lot of sense to me when I need to graph it. So I'm going to turn it into, from improper into a mixed number. So 3 goes into 8 2 times with a remainder of 2. All right, so this is going to be negative 2 and 2/3. I can graph that point. So here's 0, and then negative 1, negative 2, negative 3, 2 and 2/3. And that's enough to tell me that in this region of the rational, in this region of the graph, the rational function will look something like this. Another quick reminder that our functions will never cross, intersect, touch a vertical asymptote, but they can cross or intersect or touch, whatever word you want to use, the horizontal asymptote an unlimited number of times. All right, so now we need to decide on this part of the graph, will it go on the bottom or will it go up top? Well, I think we can determine that by finding the x-intercepts. The x-intercepts will be found in much the same way. When we find the y-intercept, x is 0, and when we find the x-intercept, y is 0. So I'm going to set y equal to 0, and I'm going to solve. Let's move this down here so everybody can see. So I'm going to substitute 0 in for y, 2 over x minus 3 minus 2. And I'm going to start by adding 2 to the opposite side. 0 plus 2 is 2. And then we have a couple different ways we can do this, but I want to teach you a shortcut. If you didn't know this, I'm able to take this exact same equation and I can flip them both. So instead of 2 over 1, it's 1 over 2. And instead of 2 over this quantity, it's x minus 3 over 2. Now, if you never learned this in 8th or 9th grade, at this point, whenever we have an equation in this form and the denominators are exactly the same, we get to cancel out the denominators and just solve for the top. x equals x minus 3. I'm going to add 3 to both sides, and I get 4 equals x. So I can come back up here. Let's see where I was finding this. 4, 0 is going to be my y-intercept. So 1, 2, 3, and there's 4. I'm going to move this down so everybody can see. And that tells me this is where the other part of the rational function will exist on the graph. Hope that helps.